Hello, hello. This is going to be a bit of a overview, a little bit of a tutorial of how I ended up making this graph using a program I wrote to extract data from the Formula One app to get live telemetry. So this is 2019 Bahrain's qualifying session between the two Ferraris, Leclerc and Vettel. This is for first and second, and this is just their velocities versus distance traveled. So I thought this was pretty neat as it gives some insight on where Leclerc is able to pull away and where Vettel is a little bit slower. And this is all taken from live telemetry from the Formula One app. So I'm going to go ahead and go over the program I made and give an overview of how it works. So the Formula One app right here gives this kind of video of live telemetry. So I went ahead and did a screen recording. That's what is being played right now. And it gives the throttle, the brakes, the velocity, its RPMs, its gears, lap times, things like that. So this program over here is something I made to extract all that data. So I'm going to go over the basics of it. I'm not going to go line by line through it, but if you have some programming experience, you should be able to follow along. So first things first, this is all based around OCR from Google Tesseract. So I just import a wrapper for Python to be able to use Tesseract. This is just so I can get Excel. I use CV2, open source computer vision, to be able to count the amount of green and red pixels, which I'll get to in a second. And then just some other things to make it easier to work with, the numbers, interpolation, and the directory. So first thing I do is set up the directory. This is just where I have my folder, or my folder set up for my video, and where I want my Excel file to end up. This, I just initiate a Excel file, start at column 1, start an active sheet. Right here, I start to analyze the video. So I start this video process. I use CV2 or OpenCV to start video capture of this MP4, which is this screen recording right here. I set up the criteria for success, which I get to right down here in this while loop. I initialize frame 0 to be the very, very first frame. And then I have these reference colors right here, which I can explain with these images right here. So these yellow, black, and red reference colors are for testing if there's a banner shown right here. I can go ahead and show you right here. There's no banner. And then when there is a banner, it kind of bumps all these down, and I need to tell Tesseract where to look for these numbers. So when there is a banner here, all these regions of interest, ROIs, that's what these are right here, get bumped down. So I read in the frame, and I read in the current frame depending on this integer variable right here, which starts at 0, and every time this loop is run through, it gets increased by 1. So I test that frame, and then I set it to be the current frame. This is just something to print saying it's a success. And then I do a color test of a pixel right around here, whether or not it's black for session is finished, red for 2 minutes remaining in the session, or yellow for caution on the track. I don't do a if not equal to one of these colors because this is a bit of a gradient. So I just test whether it's a pure black, red, or yellow. So if it is pure black or session finished, 2 minutes remaining, or caution, it bumps all these down. Again, you can see that kind of right here, how these areas get bumped down, which is what these areas are right here. All of these are ROIs, regions of interest, and these are XY coordinates of where I want the Tesseract or OpenCV to look. So for, say, velocity, I want this to be looking at just this area right here. So here are my X and Y coordinates, and then my X1, Y1, and then my X2, Y2 would be this plus this, this plus this. So that's my Y1, Y2, X1, X2 for all of these. So this is for my speed, for my RPM, that would be the X and Y coordinates. For the color, I have this box right here, just kind of an area where the green and the red are. So I test a pixel right up here to see if it's any of those RGB values, and I got that from these right here. Black is 0, 0, 0, but if it is yellow or red, it'll be different values, and I go ahead and change the ROI depending on that. And then to get an approximation of the percentage that the driver is on the throttle, I count the number of pixels that are green in this color area. So this right here sets up a min and max. Because this is actually a bit of a gradient, some of these will change. You'll see this is 16,177. I can probably find something else, especially around the border here. That'll be something else. So I have this to be a minimum green value and a maximum green value, and it will take every pixel in that range, make it white, and then take every other pixel that's out of that range and make it black, and then I can go ahead and count the amount of pixels that have a non-zero value, which is what I do right here. I start to count the amount of pixels with a non-zero value. So if I go ahead and run this program, we'll get it started, and then we'll be able to see, this isn't this exact image. This is going to be the very first frame from that video, but it's still the same max throttle. You can see it's kind of a rudimentary, not too accurate representation due to the gradient, but it gives me a rough idea. So you can see the amount of green pixels, 10,000, something like that. And then I have it mapped to be in a range 0 to 100. That is going to be right down here. So this is like the max amount of pixels that I've recorded, and I then map it from 0 to 100. So if it's the max value or over, it's 100% throttle. If it's, say, 6,000, something like that, 6,125, it would be 50%. So it gives a rough idea of the throttle. I do the exact same thing for counting the red over here for braking. However, the Formula One app, as it is right now, has brakes as a binary thing. They're either on or off, so this never changes. This is always all red or no red, so that's why I have this right here. If red is greater than 0, just set it to 1. I'm doing this in hopes that they'll update the app sooner or later so we can see a percentage on the brakes. So then I go ahead and map the amount of pixels, print the mapped throttle, print the number of red. Again, it's going to be 0 or 1. And then I call upon Tesseract. This is just a directory to my executable, so I can run Tesseract in Python. And then I start to look at the regions of interest. So for velocity, my region of interest, which I've declared up here in that if statement, is going to be right here. So I'm going to look at that. That's what we can see right here. Again, this isn't this image. This is going to be the very first frame of that video. And we can see that it says our velocity is 261. And then I'm going to go through, do that for lap time. Again, that's right. And then I guess that's all we're at. So lap time, just going to continue this. RPM, again, this is the first video frame. Gear 7, lap number. This is usually the lap number. I usually do race pace rather than qualifying. During qualifying, it's time remaining in the qualifying session. So this is not very important. And then it goes through and does it for the very next frame. It does it over and over and over until the end has come to the video. It'll be around 2,000 something frames for about a minute and a half, I believe. So this goes through automatically. I always turn off these or comment them out because we don't need this to pop out. I was just doing that for the purpose of demonstrating this code. Otherwise, it'll just churn through all those frames. One thing I have here is this language. It's kind of telling the Tesseract, not necessarily a language, but a font. Since Formula One has their custom font, I was able to train the Tesseract for the Formula One font. I'll include this F1R, that's a Formula One regular font train data that I dumped into the test data directory. And I'll include that, and I have this font lap time data that I found pretty similar to this font right here. So it's just kind of training it so it can recognize those numbers and characters more easily. And then this just says assume that Tesseract is looking for one continuous string of texts. So that's how I get the OCR from Tesseract, the optical character recognition, to recognize all the characters in their different regions of interest. And then all of this gets printed to an Excel file. I have to try to print it as a number, a float for the map throttle, and then an integer for everything else. I have to try it because if something does go wrong, say Tesseract looks at this and says it's 3 space 07, that won't be able to be converted to an integer or a string, and then it would crash. I converted to an integer because Excel doesn't like numbers stored as texts. So most of the time, it never has to go to the exception, and it works just fine. So we go through that, write it to an Excel file. Then at the end of this loop, we increase our column number to go down one column in Excel, up our frame, start all this over, and go to the very next frame, test that pixel, depending on if that pixel is that color or not, specify our regions of interest, and then we go through and test our regions of interest for all of that information. And then when it is done, when it reaches the end, it saves a Excel file based on whatever I want to name it, and then it closes out. So this is what a raw file would look like, just columns of information. That's our map throttle, our brake, RPM, gear, velocity lap, and lap time. I don't really care about the accuracy of this, as I only use it for syncing up lap times. So when this changes is when I'm interested in its information. So I don't really mind that this is all wonky. This, however, is usually pretty good. However, we will come across something like this. When it goes from 7th to 8th gear, it transitions a little bit. So this is kind of something I would go back and look at frame 63 if I wanted to, or I can just assume it's going to be 7 or 8. So with all this data, you can end up doing it for a couple of drivers and create something like this, which I think is pretty cool. Based on the insights it provides, you can see where Leclerc is pulling away and where Vettel is losing speed to his teammate for qualifying. That's about it. I'll include everything in the description. I'll include the code and that train Tesseract file, so anyone can go ahead and create this for themselves. That's all I got. Thanks, guys.